Hello guys, welcome back to Manalas Arc. I hope you've all been well. And this is a video for financial maths, and this video is meant for grade 11s. These items that you see in bullet points are the items that I'm hoping to cover in this video. It's going to take us some time, but I'm going to cover this concept. And I'm going to try to be as slow as possible because this topic has a lot of tongue twisters. It has a lot of words, concepts to them, that if I rush through things, I'm going to commit a lot of mistakes. And yes, I'm going to commit mistakes in this video because working with numbers, decimals, calculators, and all those things, it might mess a person up at times. But my mistakes won't be conceptual. It will be missing just a thing here and there. I hope so. I hope they won't be dire mistakes, right? Okay, so starting with a disclaimer here, like all the videos, you need to have a pen and paper and a calculator for this one. And then of course, in terms of a calculator, you know that you must use the Casio calculator, not the other ones, not the Sharp calculator and things. You know the calculator that we are using at school by now, right? So I'm assuming that when you're watching this video as a grade 11 learner, you already have some basics from grade 9 and 10. Things like the simple interest formula and the compound interest formula, these are not too new to you. In fact, they're not new to you. You know what these symbols mean, the accumulated amount, principal amount. By now, you know these items, okay? So I'm going to pick it from there. It's not like I'm going to make it too complicated. I'm going to pick it up from there and then carry it for you forward. That now we must end up with the proper understanding of grade 11 concepts. Here's what we are starting with. We are starting with different compounding periods, right? So let me grab a pen here. Pen, visible? Yes, perfect. I didn't even get time to test my tools that they're still working fine, but I'm assuming that all is well. Here we have this part here that says David invests 50,000 at 8%. Important information, compound interest, and now we know that we are using the compound interest formula, right? What will his money grow into in 5 years time? Another important information, if interest is compounded, here I'm starting annually, quarterly, and monthly. So I'm going to start with annually, right? What's happening? I know that I'm using the compound interest formula. Please understand that for grade 11 there are no marks for writing a formula, but I'll keep on writing it because it's the right thing to do, right? But there are no marks for writing a formula in grade 11. So buckle up, guys. And then what do I want to do now? What I want to do is I want to make my substitutions. I have my P, the current amount that is being invested, which is 50,000. I'm looking for an accumulated amount. What will his money grow to? That's the accumulated amount. So I'm going to say my A is equals to, which is this 50,000 here. 50,000, I have 1 plus my I. Now here's an interesting part. Your I always needs to be in terms of a decimal. So my I here will be 0.08. And then if you don't know how we got that, just pull out your calculator. I hope you can see my calculator there. Oops, let me fix this. We put this properly here. There we go. Hope you can see my calculator there. It's a problem. So when you want to see your I, right? Like when you want a percentage, you're going to say 8% shift percentage. You press equal sign and then you press SD to get a decimal. That's 0.08, right? There we go. So this is 0.08, and then our N is what? Our N is 5 years. So my N is 5. That makes my A to be equals to, you pull out your calculator. You don't solve things step by step. You just put this entire thing as you see it on a calculator, right? So here we go. I'm going to say 50,000, right? Open bracket. I have 1 plus 0.08, close that, raised to 5, equal sign. It gives you 73,466. Let's write that here. 73,466. Any decimals? comma 40. There we go, comma 40. Right? So this is the amount now that is being accumulated annually. There we go. This is the amount that is being accumulated annually, right? And then I'm going to write it here. My A is equals to 73,466,40. That's for question A. Now I'll erase everything else here. This is my A, right? Right there. Now I'm going to calculate for question B. So this is A, right? So for question B, how does it say? It says now I have this similar situation, but it must be quarterly. So now I'm going to do this thing this way. And from here onwards, we need to do it this way so that we don't commit any mistakes. First, I know that I'm using the compound interest formula because we already discussed this. They said compound interest, right? So I must use the compound interest formula. And then afterwards, remember now I'm calculating B. So I'm going to say A is what I'm looking for. My P is equals to 50,000. Now you see I'm taking a longer step. Does this step have marks? No. But it simplifies things for you and it helps you to avoid making mistakes. There are too many numbers in financial maths. This is the best way to go through it. Right. My interest rate is still 8%. The only different thing is that it's being compounded quarterly, right? So my interest rate is still 0.08. But the new thing is that now it's being compounded quarterly. Now, what does quarterly mean? In 1 year, how many quarters do I have? I have 4 quarters, right? I have 4 quarters in 1 year. Term 1, term 2, term 3, term 4, right? There we go. So if I have 4 quarters in 1 year, it means now this interest that I have of 8% per annum compounded, it's going to 4 times in a year, because of they're saying this is 8% per annum compounded quarterly, right? So this I'm going to divide by 4. What else is being affected by that statement? It's N, right? Remember, N now represents the compounding period, right? So this thing, it has been invested for 5 years. But remember that interest is being compounded quarterly. So each and every year it's being compounded 4 times. So even though the year it's 5 years, it's still being compounded 4 times each year. So it's 5 times 4. And then now I make my substitutions into this formula. So since I'm calculating my A, this is going to be equals to my P is this one, which is 50,000. 1 plus, my pen is not writing properly, I don't know why, but excuse me, it will adjust along the way. Right. My I is what? It's this one, which is 0.08 over 4. There we go. My N is what? My N, it's 5 times 4, as we discussed it here, right? And then again, you're going to put this entire thing on a calculator. Pull out your calculator. So here it is. Here are my values on a calculator. My I is divided by 4. My N, it's multiplied by 4. And my answer there, it's 74,297, right? So let's use that. My A is equals to 74,297. Any decimals? 0.37, rounded off to 2 decimals. 0.37. Now let me write it here. My accumulated amount in question B, that is 74,297,37 cents. You see that? And then now the last part. But the last part, by now, I'm sure you can do it because you can see how we do things. So again, what happens here? First of all, I know that I'm using the compound interest formula. Right? And then afterwards, I attribute every item to what it's worth. I know that I'm looking for A, so my A is unknown, right? my P is equals to 50,000. This is 50,000, right? And then afterwards, I'm going to say my I is still 8%, which is 0.08, because it's compounded monthly. If I'm compounding something every month in 1 year, how many times am I going to compound it? I'm going to compound it 12 times, right? What else is affected by that compounding period? It's my N. If something is being compounded for 5 years, if an investment runs for 5 years and each and every year it's compounded monthly, it means I'll multiply that 5 years by, sorry, not by 4, but by 12 for 12 months. And then I'll make all my substitutions here. My A will be equals to the principal amount, which is 50,000, right? This is 50,000 into 1 plus my interest of 0.08 over 12. This multiplied by 5, raised to 5 multiplied by 12, right? You put all this on a calculator again. This is equals to 74,492.29, right? So here we go. You put an SI unit, which is rents. That's 74,492.29, if I remember properly. There we go, right? These are the different compounding periods that I have with my situation that I had here. So I bet now you can do any question that has different compounding periods. Now to the next one. In this question here, I have a situation of different compounding periods again. But then here it says Thulani borrows 2,000 with an agreement that he will pay back 3,000 exactly 2 years from now. Do you see that? He borrows 2,000, and then after 2 years, which is N, you have to keep on highlighting these things. You have to, right? So I have 2,000, right? He borrows 2,000 now, which means this is my P, right? He borrows 2,000 now with an agreement that he will pay 3,000. He's going to pay this amount at the end after 2 years. So 3,000 is the accumulated amount, right? And then for how long? For 2 years. But this 2 years now, it says calculate the interest rate charged per annum, right? Compounded monthly. So we are looking for I basically here, né? And I'm going to come back to this 2 here. We are looking for I, and then the I that we are looking for, the value for I, it said that it's being compounded monthly, which means per year it's going to be compounded 12 times, which means same applies to this N here. Since it's 2 years and we are compounding every month, this is going to be 2 times 12, right? So what formula are we using? We are using the compound interest formula here. Okay, so I'm going to say my A is equals to P 1 plus I that I'm looking for, and that I it's over 12 raised to the number of years, and the number of years must also be multiplied by 12 because everything is compounded monthly. Right, so substitution, I have the A. My A is 3,000 is equals to my P, which is 2,000, 1 plus the I that I'm looking for over 12, and this is raised to how many years? 2 multiplied by 12. And then what happens in this situation? What happens in this situation is that I need to isolate I from everything that I see here, right? Now let me choose a different color here. Usually I use orange. So first I have to remove the 2,000. So I'll divide this part by 2,000. And I'll also have to divide this part by 2,000. So this part will cancel the 2,000. This 0 cancels this 0. This 0 cancels this one. And this one cancels this one. I'm avoiding to work with decimals. Please bear in mind, you need to avoid decimals and only work with fractions or whole numbers. What am I left with on this side? I'm left with 3 over 2. Don't put it as a decimal. Put it as 3 over 2. This side, what am I left with? I'm left with 1 plus I over 12 raised to this item here, 12 times 2, which is 24, right? Which other number it's more removable here? Well, if you did your algebra good in term 1, you would know that the most removable number here is 24. So I need to remove 24 by a root of 24, by root 24. So root 24 of this number here, this number which is 3 over 2, is equals to this bracket, 1 plus I over 12 raised to 24. And what I do on the left, I also do on the right. This thing here, I know it's a flying root. In fact, let me fix that. It's irritating me. Right, let's put a proper root there. Much better, right? So this 24 will cancel the 24 exponent. Remember, avoid decimals. Keep everything as it is, because you also want to reduce touching your calculator too many times. So here I have the 24 root of 3 over 2. This is equals to, now that I've removed this exponent, I no longer need the brackets. I have 1 plus I over 12. Now, what is easier to remove here? What is easier to remove in this case? It is the 1. 1 should go to the other side, right? Because I'm solving for I, remember that. Here I'll be having 24 of 3 over 2. 1 to the other side becomes minus 1. Bear in mind, the 1 is not inside the square root because it came later after the square root was put in. This is equals to I over 12, right? Now what do I need to do? I need to multiply everything by 12. Now let me write everything then. I have 24 of 3 over 2 minus 1. This is equals to I over 12. So let's pick a different color here. I'll multiply this entire thing by 12. And what I do on the left, I must also do on the right. So numerator 12 will cancel denominator 12. Right, and then let's create some space here. I'm almost done, so I don't need too much space, to be honest. What I'm getting now is that my I, the I that I'm solving for is this one. Now the I is isolated from everything else. So my I is equals to 12 into the 24 root of 3 over 2. This is inside the square root, minus 1, which is outside the square root, close bracket. Then I'll put everything on a calculator here to get my I. So when I punch this on my calculator, I'm getting I is equals to, I need to write it to 4 decimal places, right? That is 20, let's point at it. This is 24, 5, because this 5 will round off this 4 to be 5, right? So 24, 5. So my I is equals to 0.24, 5. Now that's an I as a decimal. I need to give them the rate now. The rate which is in the form of a percentage. The interest rate, right? So my rate is equals to 0, my pen it's misbehaving now. My rate is equals to 0.2045. I'll multiply this by 100 to get my rate. Therefore, my rate is 20.45%. Do you see how nice is that? This is my rate now. So, this is how you would always do it. This is how you will always do it. Let me write my rate. In fact, there's a full statement. My rate is 24.45% per annum compounded monthly. Because it was per annum compounded monthly. You see that? So these are the calculations I would expect you to do. I would expect you to do these things for me. Very beautiful. And I hope it won't be confusing for you too when you get here. All right. So now I want us to talk about the effective and the nominal interest rate. Now these items, the nominal and effective, right? The nominal interest rate and the effective interest rate. So usually when you have statements would appear to you with a nominal interest rate. Like for example, there's a statement that can say 10%. Wait, what is this pen doing? The statement can say 10% per annum compounded monthly. Now, what we realize here is that this statement, the reason we are saying it's a nominal interest rate now, it's that it has two different periods. When we have the part that says per annum, this means per year, right? And then afterwards they say compounded monthly. So I have 10% that is being charged per year, but it's also compounded monthly. So it's two different periods. That's what we call a nominal interest rate in this situation. So with the nominal interest rate, you'll get to realize that eventually the actual effect the money grows by, it's different. It's slightly different from the one that they gave you. For example, let me give you an example. Let's say you're investing 100 rands for 1 year, right? At this nominal interest rate. Now, naturally, if you're investing 100 rands for 1 year, and then we are saying that your money must grow by 10%. Basically, we are saying 10% of 100 rands, right? That money should grow by this 10% at the end of this year. And then how much is that? Well, 10% of 100 rands, it's 10 rands, right? So the interest here, it should be 10 rands, which means by the end of the year, you should be having 110. Right? That's what 10% will be like for that year. So if I'm saying your 100 rands, you're investing it for 1 year, it grows by 10%. At the end of that year, you should have 110. Right? But then what you get to realize now is that when the money is being compounded at a different period from the interest rate, things are slightly different. And I'll keep this 110 here. Right? So in financial maths, we'd look at this statement and say, wow, this statement here needs me to use the compound interest formula. Like this way. Right? And what I know about my compound interest formula in this situation is that I'm looking for my A. How much will my money grow by in 1 year? And how much was my P? I said I'm investing 100 rands. I said I'm investing 100 rands for how long? For 1 year. Right? But in that 1 year, how is it being compounded? It's compounded monthly. In 1 year, I have 12 months, right? Then my I now, it's going to be equivalent to 10%, which is 0.1. Again, if you don't know how to find this, use a calculator. All over 12 because it's compounded monthly, right? And then what do I see? When I make substitutions to this, I'm going to have A is equals to my 100 rands, 1 plus 0.1 compounded monthly in 1 year multiplied by the compounding periods. My A will be equivalent to, pull out my calculator here, right? And I'm going to say 100 rands into 1 plus, let's put a fraction to it there, 10%, which is 0.1 divided by the compounding period. Close that, raise this to 12, right? This gets me how much? 110.47. Look at this. This is 110.47. Now you see, initially what did we get? we got 110 rands because we said if this money grows by 10% for 1 year, at the end of the year I should have 110 rands. But when we make the proper calculations using the compound interest formula, we realize that actually the money is going to grow to 110.47, which means my interest here is 10 rands, 47 cents. So this money, if I have to write it in percentage numbers, I'm going to say this money grew by 10.47%. This is the real effect that occurred to this money when I was compounding it monthly. So we call this the effective interest rate. So when I invest my money at 10% per annum, compounded monthly, this 10% that is being compounded in different periods, this 10%, it's the nominal interest rate. But how the money will actually be affected, it will grow by 10.47%. And this percentage, now we call it the effective interest rate. The actual percentage that the money will grow by the end of this year, it's this one, which is 10.47%. Now, several times now in this subject, you're going to be asked to convert your interest from the nominal interest rate to the effective interest rate, which is the actual interest that the money will grow by. And for you to do that, there's a formula for it. And the formula goes as follows. The formula says, in fact, let me erase many things here. Let's remove this. The formula for the situation says 1 plus I and a subscript of EFF is equals to, into brackets, 1 plus I with a subscript of norm over M, close bracket, raised to M. Right? Now, what are your things here? Your IEFF, it represents the effective annual rate. And then your I norm represents your nominal annual rate. Is this how to write nominal? I think so. Annual rate. Hope it's visible there. And then your M represents the number of compounding periods per year. Right? So in this situation, our money was being compounded monthly. So it means our M would be 12, because something that is compounded monthly, it's being compounded 12 times per year. Do you see that? So this is the formula that you will use now to convert your all your nominal interest rates into effective interest rates. Like easy as that, guys. Right? Now let's pick up an example. Here's a question here. It says, what is the effective rate for a nominal interest rate of 10% per annum compounded semi-annually? Right? So if I'm investing money with this effective rate of 10% per annum compounded, how much am I actually going to get by the end of the year? Or if I'm taking a loan from a bank and then they are saying to me, well, we are going to charge you a nominal rate of 10% per annum compounded semi-annually, how much am I actually going to pay, the real effect of my loan by the end of the year? Right? So let's do that. Whenever I have semi-annually, you always use the formula that I gave you for converting. It's IFF is equals to 1 plus I norm over m raised to m. Right? This is what we discussed. So now for me to get the effective interest rate, I'm starting with question A now. I'm going to say 1 plus IFF, which is what I'm looking for, is equals to 1 plus, what is my nominal rate? This is my nominal rate because I have 10% per annum, but it's compounded with a different period, right? So my 10% here is 0.1 over my compounding period. If I'm compounding semi-annually, it means I'm compounding 2 times a year, right? Semi-annually, it's 2 times a year. And then also here, I'm going to have 2. Now, when I look for my IEFF, it's going to be equals to 1 plus 0.1 over 2 raised to 2. I'll take this one to this side. Now it becomes minus 1. Do we see that? Now, my effective interest rate will be equals to, you can pull out your calculator here. And then boom, with my calculator, what I get is this. Then I just press SD here. I get to 4 decimal places, 0.1025, right? So this is 0.1025. So the effective rate is equals to 10.25% because I'm going to multiply the decimal by 100. Do we all see that? Now, I'm sure by now you've attempted B on your own, so let me quickly do it. Substitutions. I'm going to have 1 plus IEFF is equals to 1 plus my nominal rate of 10%. Compounding period, it's 12 raised to 12, right? So my IEFF will be equals to 1 plus 0.1 over 12 raised to 12 minus 1. And then here my IEFF is going to give me how much? Using my calculator here, I get 10 to 4 decimal places. It's 1047, 0.1047, right? Let's write that. 0.1047. Now, what is the rate there? The rate is 10.47%. This is the effective rate compounded monthly. This is the effective rate compounded semi-annually. Are we good? So we are done when it comes to talking about converting an effective interest rate, a nominal interest rate into an effective interest rate. By now, if you get a question that needs that from you, you should be able to kill it. Are we good? Moving on to the next part. Here's the last question, which can be a level 3. I said we are done, but I think this question is very nice. Here's one question that can be a level 3 for you. They are saying if an interest rate of X% per annum compounded monthly is equivalent to an effective rate of 9.38%, calculate the value of X. Right. So still effective and nominal interest rate. Now what I have here is that I have this situation. This situation here. I need you to bear in mind that I see per annum, I see compounded monthly. What type of an interest rate is that? By now you should know that it is a nominal interest rate. So my I norm, it's unknown now. So I'll refer to this as X because they told me that it's X. My I norm is X. My IEFF, they're saying the effective rate is 9.38%. Now remember, we always want to write things as decimals, and if you can't convert a percentage into a decimal, use a calculator. Now I make substitutions. The formula says I effective plus 1 is equals to, right, 1 plus I norm over m raised to m. Now I have the I effective. I effective is 0.0938 plus 1. This is equals to 1 plus X, which is what I'm looking for. How many times is it compounded? It's compounded monthly. So if I'm compounding per year, I'm going to compound 12 times. Right? And then afterwards, I can basically add these things together. It's not rocket science. This is 1,0938. And this is equals to 1 plus x over 12 raised to 12. How do I remove the 12? I put the root 12 there. So I'm going to put root 12 here. And I'm going to put root 12 here. There we go. So this will be removed by its root. So basically here I'm left with a root 12 of 1,0938. Bear in mind, I haven't used the calculator. You always must just use the calculator at the end. Now there is no longer anything holding the brackets, so I can leave the brackets out. I have this item now. Right. Then afterwards, between 12 and 1, what is removable? 1 is removable. So I must transpose 1 and send it to that side. What do I have? I have root 12 of 1,0938. I'm going to subtract 1 outside the root. This is equals to x over 12, right? Then I need to multiply everything by 12. So I'm going to say this whole thing multiplied by 12. I need to keep on switching colors so that people can actually get what am I saying or what am I doing, right? So this is 1,0938 minus 1 is equals to x over 12. What I do on the left, I need to do on the right. Because I multiplied by 12 here, I'll also multiply by 12. So numerator 12 cancels, denominator 12. Do we see what I'm doing here? Hope so. I hope so. Right. So now this gives me x being equals to 12 multiplied by the 12th root of 0,938 minus 1. The 1 is outside the square root. Now let's use a calculator here. So this is what I'm getting on my calculator, and I need to write a value to 4 decimal places, right? So this is to 4 decimal places. I have 0,08 and I see 99. I was supposed to end here. So as I'm supposed to end at 9, this 9 will affect this 9. So when I round it off, this will become a 10, converting this to a 10, converting this to a 9. So to 4 decimal places, this is going to be as follows: 0,0900, right? This is what I'm getting as x. And then for me to get a rate, of course, I'll multiply this by 100. This is 9% per annum, compounded monthly. There we go. Right? So it was not all that bad. Any question that has nominal rate to effective rate, you should be able to kill those questions. You should be able to, please. Right? By now you should be good at those things. Now I want us to move to the next item. Now we are actually moving to the next item. With the next item on the list, we have a concept that is called depreciation. Now, what is depreciation about? Depreciation is basically about the fact that every item you buy, it loses value. Now, in the world, we don't like being uncertain about things. When you buy a car today, we don't want to be uncertain about the car that you bought today. How much must you sell it for in the next 5 years? There's a formula to calculate that. There's a formula, and then now you're going to be able to calculate the concept of depreciation. So when you buy, every item that is an asset depreciates. Something that is out of the shop and it's now being used, it loses value, right? If you buy something for 80,000 rands today, in the next 2 years, you're not going to sell it for 80,000 rands, right? You're going to sell it for a much cheaper value, okay? So every asset that is being bought, any asset, it loses value. And that's the whole concept of depreciation. So now with regards to depreciation, we have two types of depreciation, two formulae, right? The first formula, just like the way we have simple interest and compound interest, the first formula is called the straight line depreciation. Now that's the one that uses the simple interest formula, but it's like in a reverse form, because of now here instead of having plus we have a minus, right? And then afterwards we have the reducing balance depreciation, in which you would have guessed this one uses the compound interest formula, but instead of having a plus sign in between we have a minus sign, right? And now to go through the items, number one, the A here will represent the depreciated amount, and then P, it will represent the original amount or the principal amount, and then of course I will represent the rate of depreciation, and then N in this case will represent the number of periods. So I'm writing this because I know there are people who would be watching videos taking notes. So even though it takes time for me to write these things, it's actually worth it, right? So now here are the items we have. You shouldn't struggle with these concepts, right? So if I buy a car today, the car will have its original amount. Let's say the car is 100,000. In the next 5 years, the car will no longer have an original amount. It will have the depreciated amount, because of now it's out of the shop, right? It's being used now. So its depreciated amount, it will be much lower. So in this case, when we are calculating depreciation, our A should be lower than the P value. Also here, our A should be lower than the P value, right? And then here we have the rate of depreciation. You'll usually be given the rate of depreciation. If not, it means that's what we are asking you to do, to calculate. Similar to the way you use the compound interest formula and the simple interest formula. And then bear in mind that in grade 11, we keep on referring to N, not as number of years, but as the number of periods, right? So now let's get into this example and see the meat and bones of these things. So here I have a question that says the value of a vehicle worth 200,000 depreciates at 12% per annum, right? Calculate the value of the vehicle in 5 years' time if the depreciation is calculated using the straight line method, right? So straight line method and reducing balance. So let me cut this into two. Okay, in fact, it's fine this way. Right, calculators are important here. Straight line method, it means I'm going to use the straight line formula, right, which is this way, 1 minus in, right? So substitution, I'm looking for the value of the car in 5 years time, right? How much will the car be worth in 5 years time? So the original amount of the car is 200,000. I have 1 minus rate of depreciation. We don't call it interest now because it's not a gain, it's a loss. It's the depreciation rate. So 12% as a decimal, again, that is 0.12. If you don't know how to do this, put 12% on a calculator, press SD, you'll get a decimal, right? So they didn't say it's compounded for any period, so we just take it as 0.12 this way, right? This is running for how long? For 5 years. Look at that. Throw this on a calculator. Oh, I'm realizing this as I'm calculating now that this is not supposed to be compound because I'm using the straight line, which is this formula. This 5 should be inside. Let me do it. Let me fix it. So back to the calculator. Multiply this by 5. This is equals to 80,000. Doable. So which means the vehicle that we bought for 200,000 5 years ago, today it's no longer worth 200,000. It's worth 80,000 because it lost value, right? That's using the straight line method, And now let's use the reducing balance method. The reducing balance, remember, it looks like the compound interest, but except that now we are losing, right? So my principal amount is 200,000. I have 1 minus the interest, which was 12%. This is 0.12 raised to 5. Now my A here will be equals to, pull out a calculator there. This must be raised to 5 years. And then this, I'll erase this because I no longer have this inside. And this will be equivalent to 105. Let me just write the value. 105,546. 105,546, comma, what was the decimal? Comma 38 to 2 decimals. Mine is always to 2 decimal places, unless they tell you otherwise. This way. So, this car in 5 years, if it was depreciating using a straight line depreciation, this vehicle will be worth 80,000. If it was using the reducing balance, this vehicle will be worth 105,000 roughly, right? Now bear in mind, it might seem like losing through reducing balance it's better than straight line balance, but that's not the case. Remember, just like the compound interest situation, when you use the straight line balance, your money, it loses constantly like this, right? So if this car keeps on losing 10,000 every year, it'll be 10,000, 10,000, 10,000, 10,000 throughout. But with the reducing balance, it first starts looking like it loses less up until it loses faster, because it's like an inverse exponential graph or a negative exponential graph, right? So at the end of a longer period of time, the reducing balance will lose more money than the straight line depreciation. I hope that's good. Let's move on to the next part. Right. Oops. My PC is a bit slow. But then here we go. Now, the next part that we want to talk about is inflation. Now I'm going to read here. Inflation as we know it. This is the concept of things losing value. Not things. This is the concept of money losing its value over time, right? Now, how do we say money loses value over time? Money is money. So which means if I have 20 rands today, 20 rands today might be able to buy me bread today. But in the next 10 years, my 20 rands won't be able to buy me bread at that time, because things would have risen in value. My money will be worth less in that time, right? So that we call inflation, that things keep on rising in terms of prices. Like how much bread is today, it's different to how it was 10 years ago, and it will be different to how much it will be 10 years from now, right? So whenever we are calculating situations of inflation, whenever we are calculating situations of inflation, bear in mind that inflation always uses the compound interest formula, right? And then usually inflation is calculated annually, right? Okay, so here's an example. Okay, it also talks about bread. It says a loaf of white bread currently costs 14 rands. How much will a similar loaf of bread cost in 5 years from now, if we are saying that inflation is 7.5%? 7.5%, right? So now, remember what we said? This always uses the compound interest formula this way, right? So which means if I'm looking for the amount in future, the future amount, I'm looking for A. The principal amount at the moment, it's 14 rands. I have 1 plus my I, which is 7.5%, that is 0.075 raised to 5 years. All right, what am I getting there? I can pull out my calculator now. With my calculator, remember, inflation is always calculated using the compound interest formula. So bread in 5 years time, it will be worth 20 rands, comma, when we round this off to 2 decimal places, this is 10, right? So 20 rands, comma 10 cents. There we go. Bread that costs 14 rands today, it will cost 20 rands, comma 10 cents next time. Nice, right? Doable. I think it's raining outside. I hope my mic won't capture that background noise. So this is inflation, guys. Inflation. Let's move on. On this part, we are talking about the concept of timelines. Now, let me tell you what happens in timelines. What happens in timelines is that you would get a statement like this. It's not like the question paper will tell you that, okay, guys, this is no longer a nominal and effective interest rate type of a question. This is a timeline question. No. You have to look at a question and see that this is a question that needs a timeline. And usually, how do you see that this question needs a timeline? The question will give you a statement, and afterwards, the statement will only be valid for a certain period, just a short period, let's say 3 years. Afterwards, they give you another statement which works for another 2 years. And then maybe they'll give you another statement which will be valid for the next 3 years. And then you have to combine these statements now, build a timeline with them, because they operate on different times. Right? Now, I'm sure that's confusing. Let me actually show you what I mean by that. So here we have the following. Says Spusiso deposits 15,000 rands. We see this. This is the money now, right? He deposits this money now. Okay, we'll come back to this. But let me just put a P on top of it there, right? Into his bank account and leaves it in the bank account for 5 years. Now, do you see this? This is time, all right? This is N. It says for the first 3 years. Now, do you see? There is something that only happens for the first 3 years and not for the other 2 years in that 5 years. For the first 3 years, interest is calculated at 8% per annum compounded monthly. Thereafter, the interest changes to 9% per annum compounded quarterly. How much money will he have in his account at the end of 5 years? So here's what you do here. You create a number line. And this number line, this is year 0. And then this is year 1. Usually we use T's here, right? T0, T1, T2, T3, T4, T5. This is the end of year number 5. So when you count like this, that's year 1. You count like this, that's year 2. You count like this, that's year 3. Count like this, year 4, and then year 5. See that? So now, here's what we have. We have this initial 15,000. So I want to put this 15,000 here. I'm going to say plus 15, not 5. See, I'm making mistakes. 15,000. I'm going to say plus, right? Because he deposits 15,000 in the beginning of year 1, right? The beginning of year 1 is not here. This is the end of year 1. So in the beginning of year 1, he throws 15,000, right? So what's happening to that 15,000? That 15,000 stays in the account for the first 3 years with an interest rate of 8%. So, which means from here, I'm counting 1, 2, 3, which means up until here. From here up until here, I have an I that is as follows. My I here is 3 years. I'm sorry. My I is 8%. Compounded monthly. So this is 0.08 divided by 12. I hope that makes sense, right? That's my I for 3 years. And what's my N there? My N is 3 years multiplied by 12 also. Do we see that? This happens in this space. I'm using this sentence now up until here to build this information here. And then afterwards, I need to build another information. It says thereafter. Let me use a different color here. It says thereafter, which means it's for the remaining 2 years. From here up until here. That's 2 years, right? What do I know about the other part? The other part says my I there, my interest is 9% compounded quarterly. All right, you're interpreting a question first before you start answering. So that's 9%, which is 0.09 compounded quarterly. How many quarters do I have per year? 4. And my N also is going to be equal to, remember now I'm running for the remaining 2 years. So that is 2 years multiplied by every quarter per year that's happening. Do you see that? So how much money are we going to have at the end of 5 years? What you do, you realize that you have two situations that are different here. First, you have this white situation, then you have this brown situation. Right. So let me put this 15,000 here. It's taking space. Let me say in the beginning here, I have plus 15K right here in the beginning. Right. So what happens now? Everything here says compounded. I'm using compound interest throughout. So I'm going to say my formula is equals to this young bad boy here. Right? I'm looking for the accumulated amount at the end, but I cannot just find this accumulated amount. First, I have to find the accumulated amount here. And then I'll come back to find the accumulated amount here. This is the final accumulated amount that they want. So my A2 is actually what I want. Are we good? So I'm going to start here because I need A1 for me to be able to calculate A2. And I'll show you how. So I'm going to say now, starting with the white one, for me to get the accumulated amount here, I'm calling it accumulated amount number 1. What happened? In the beginning, they deposited 15,000, which stayed in there. For this white part, my interest was 0.08 over 12 raised to n times, 3 times 12. Right? This gives me an initial accumulated amount. Let me use a calculator there. So I've inserted these things here. Let me just press equal sign. I'm getting 19,053 right, 56. 19,053,56. Let's put it here. 19,053,56. Now I want you to understand what is happening here. Right, I want you to actually understand what is happening. I'm going to use a blue color. I hope it will be visible when I edit this video. You see this amount here, this A1. This A1, it is the accumulated amount of this 15,000 here at year number 3. Are we good? So I calculated this 15,000 up until year number 3. Where else this question is running for 5 years. But what I did, I calculated up until year number 3. Why? Because after year number 3, things change. Right? So the money that I have now in the end of year number 3, in the end of year number 3, the beginning of year number 4 now, I'm only left with year number 4 and year number 5. So at the end of year number 3, things change. I now need to dump the old methods and use the new methods here, right? So which means the money that I have now, let's use orange. I'm still going to use compound interest because this 9% was compounded. So the money that I have now, I need to recalculate it for me to get an accumulated amount number 2. Now, the only major thing that you need to understand here is the concept of P. That the P that I put here, it's not the 15,000, because at the end of year number 3, I no longer have 15,000. That 15,000 has matured into this amount. So now it means my P is equals to A1. Is it making sense? So at the end of year number 3, I no longer have 15,000. That 15,000 has accumulated interest. It's now sitting at 19,000. So my principal amount there, it is my A1. So which means my A2 is equals to my A1. Where I see P here, I'll put 19,000 because of that's what I have now currently, comma 56. And then I use the compounding things there. My I is what? My I is this one because of now we are using new information. Compounded quarterly, raised to how many years? The remaining 2 years. The remaining 2 years, remember, it's compounded quarterly, so it's raised to 2 multiplied by 4, which means now the final accumulated amount is going to be as follows. Let me use a calculator. So here we go. Here are the details. Press equal sign. This is equals to 22,765. 22,765. So I have 22,765, comma 78. 78 rands. So this is the final answer now. At the end of 5 years, after we considered all these calculations, the amount of money will be worth this much. Hope it makes sense. It's beautiful, isn't it? It's beautiful that things keep on changing in these timelines, and you have to consider that and actually calculate it without making mistakes. It's beautiful. Let's move on to the next part. Now, on this part, what I want to do now, this is a nice one. I'm actually making a calculation that has a deposit and it has a withdrawal. So you see what's happening there? Very tricky. This money must have a deposit and it must have a withdrawal. And if I make a mistake here, I'm not going to edit this video. I'm just going to cancel out and restart afresh, which means a longer video for you, right? But I want you to see the suffering of it throughout. So here's what we have. Let's read the statement. It says Cheryl's bank. So the Cheryl, is it Cheryl or Cheryl? Right? It offers 3% per annum compounded monthly on her savings account. She opens the account with a deposit of 12,000. A year later, she deposits another 5,000. Another 2 years later, she withdraws 8,000. How much money will be in her bank account 5 years after the account was opened? Very tricky. Very tricky, but we can see there are so many breaks in between, so which means this is a timeline. Remember, we're not going to tell you that the question is a timeline. You are just supposed to know that it's a timeline. So this is happening for how long? Boom, boom, boom. When I read the statement, I see that this is happening a year later, another 2 years later. How much will be after 5 years? So it's 5 years. 2, 3, 4, 5. 1, 2, 3, 4, 5. So the beginning of year number 1, end of year number 1, year number 2, end of year number 3, end of year number 4, end of year number 5. Right. So what's happening? What's happening is that they are saying this person opens an account for 12,000. So here she deposits 12,000, right? Please bear in mind that drawing timelines on the exam, they do not have marks, but they are very important for you. Okay. So down with the 12,000, I wrote it. It says a year later, she deposits another 5,000. So which means right here, she deposits another 5,000. Interesting, right? So I've done the statement. Another 2 years later, she withdraws 8,000. Right? So another 2 years later, which means from here, 1, 2, she withdraws 8,000. Do you see that? And then afterwards, it says what? How much money will be in her bank account after 5 years? So which means we want the accumulated amount here. And then what's happening is that this thing throughout, it's 3%. So which means from here up until here, our I is equals to 0.3 compounded monthly. Oops, let's fix this. Compounded monthly means we're going to divide by 12. Right, so you see what's happening. So now I want you to understand, every time there is something happening, we have to stop and recalculate again. That's my best way, because there's a long steering method that people use, or the ones that textbooks use. They get to be confusing for learners. So what I do is that I calculate at each and every point. Every time something happens, I stop, I recalculate. What do I mean by that? I'm going to calculate here. I'm going to calculate here. I'm going to calculate here. And then so that we can see how much we have at the end. Do you see how much work we have? Yes. So I'll use orange. I'm going to start here. Throughout here, I'm using compound interest. You can see compounded monthly, right? Compounded everywhere. So I don't even need to write the formula. I'm going to say my A1 is equals to the principal amount. The principal amount is this one, so 12,000. I don't even need to write that. And in your steps, in your calculations, you don't need to write the SI unit. So 12,000. I have 1 plus my I. My I throughout is going to be this 0.03 all over 12. So I'm going to calculate this from here up until here, right? How long am I running for? I'm running for 1 year, so that's 12, right? 12 times 1 year, right? Remember, it's always compounded monthly, so I always multiply by 12, which means my accumulated amount now up until this point, it's going to be as follows. Let me put that on a calculator. So my calculator is telling me 12,364. 12,364. Let me write it here. 0.99. 12,364,99. Now, why did I calculate up to this far? Because after this point, there's another transaction that happens, which is this one now, right? So this transaction now, I'm going to add it here with a different color. Let's choose white. So I'm going to say plus 5,000, right? Because this person is depositing 5,000, which means my A1 in total, my A1 is going to be equals to, where's the calculator? I'm going to take this amount and add 5,000. I'm getting 17,364,99. 17,364,99. Are we good? So that's what I have now. Let me erase this because we already know what it is, right? So let's not suffer this thing. It will forever be 0.3 compounded monthly. So now what's happening? What's happening is that now at this point, I need to consider that how am I going to move forward with my calculations. So now that I'm here at the end of T1, I have A1. I have this amount here, right? This amount, I'm going to carry it forward up until the next transaction, which means I'm going to carry it forward for 2 years, right? I'm carrying A1 for the next 2 years, which means my principal amount now is going to be equivalent to A1 on my next calculations. So what is the formula? The formula says A is equals to P1 plus I over 12 raised to the next 2 years. Remember I said I'm calculating from here up until the next transaction. So which is n times 12. Remember that interest, it's always compounded monthly, right? So now my A2, because I've already calculated A1, my A2 is equals to this amount, which is 17,364,99. 1 plus my interest is always 0.03 over 12 raised to 2 years multiplied by 12. This means now my A2 is equals to, let me write it smaller, pull out a calculator. I'm taking this amount now, this answer. I'm going to say 1 plus 0.03 over 12 raised to 2 years. 2 years times 12. This is equals to 18,437. Right? So let's take that. I'm having now 18,437, comma 40. 18,437,40. Do we see that? And then what else happens at that situation? What else happens is that there's a withdrawal. There's a withdrawal of 8,000. That's why we calculated up until this transaction. So here I'm removing 8,000, which means my A2 is equals to, pull out a calculator again. Whatever money I have here, I'm removing 8,000, equals to, what am I left with? 10,437. 10,437, comma 40. Do you see what's happening? I'm here now. What's happening here? Here I have A2. Right? So this A2 now, I have to calculate it for how long? For the next 2 years. From here to there and up until there. That's 2 years. Right? Let me erase this part here. You see how timelines are interesting. Very interesting. So again, using the compound interest formula, I have A is equals to P1 plus I over 12 and N times 12, because it's still compounded monthly, whereby my P now will be equals to A2, and A2 it's this amount here. Are we good? So substitutions. I'm looking for A3 now, my final accumulated amount, which means I'm calculating from here, in which here I have A2, that's the amount I have now. I'm calculating this A2 for the remaining 2 years. So A3 is equals to A2, which is 10,437, 40 into 1 plus 0,03 compounded monthly, running for the next 2 years, compounded monthly, which means my A3 is going to be equals to, you pull out your calculator again, this amount, that's my answer. I'm going to say into 1 plus the same compounding period over 12 raised to 2 years multiplied by 12 months. Here we're getting how much? 11,081. 11,081, comma 99. There we go. So we are saying now at the end of 5 years, this is the amount of money we have. This was so interesting. Did you see how much we had to go step by step, calculating this from that, taking this as the next present amount, calculating it to the next point, and then take that as the next, like you see all those nice things. That's what I expect from you on the test when you are writing. Take things step by step. Let me see your methods throughout, and let's see how you work throughout, right? Okay, to the next question. Let's get a more juicy one. Timelines again. Multiple payments and withdrawals again. So here we have a very tricky timeline, because actually what we are looking for here, it is the amount of money this person is supposed to invest in the beginning, right? And which is a problem. Okay, let's read the statement. It says, Simba intends to give 100,000 to each of his 3 children when they turn 18. They will turn 18 in 1 year. The first one will turn 18 in 1 year. The second one will turn 18 in 3 years. Another one will turn 18 in 6 years. It says he will give them the money on the same date as today in each respective year. For this purpose, he immediately invests a lump sum of money into his savings account, which pays 6% per annum compounded monthly. How much is he supposed to invest? Now, this is a problem of a question. Let's see why. Right. I need a straight line. Let me draw it quickly. So here I drew it. I hope it's visible. Fair enough, right? Let's fix this a bit. Just a little bit. Right. So right here. Right. This is happening over a period of maximum 6 years from now. Right. So I'm going to do this here. I have T0, T1, T2, T3, T4, T5, T6, right? Beginning of year 1, end of year 1, end of year 2, end of year 3, end of year 4, end of year 5, end of year 6. You see how I did that? So, and then afterwards, I want to show you something. Like this is very tricky. We want to know how much money he should input, right? Like how much money should be in here, right? We want to know how much money should he deposit, right? And then what we see is that throughout the interest rate is 6% per annum compounded monthly. This pen, it's failing me. 0.06 over 12 throughout. That's one thing we know, right? And then so now the important part, it's the kids, right? 1 year from now, which is exactly here, he's supposed to give a child 100,000, 100K, right? And then in 3 years, another one will turn 18 again. So 1, 2, 3, another one will turn 18. So he needs to give out another 100,000, right? And then in 6 years, 1, 2, 3, 4, 5, 6, of course, another one turns 18. He must give 100K again, right? So what we know is that at the end here, he's supposed to be having 100K in his account to give his child. Here he must have 100K that he will be able to give a child. Here he must have 100K he will be able to give a child. So we want to know how much must he deposit so that by the end he'll have his final 100K to give to a child, right? So I want you to understand that basically here we are counting backwards. That's the tricky part of this thing. That here I'm counting backwards. I have a situation from here up until here, right? And then remember, this is compounded monthly. So I have my end here being 3 years, right? 3 years in terms of months, that is 3 times 12, which is 36 months, right? And afterwards, I have this situation where I'm calculating from here up until here. That is 2 years. So my end here, it's like 24 months, right? It's 2 times 12, which is 24. And afterwards, I have a situation from here up until here, and that is 1 year, which is like 1 times 12, which is 12 months, right? So this is my timeline. So in this timeline, I know he must withdraw 100K to give to a child. He must withdraw 100K to give to a child. And here, finally, he must withdraw the last 100K and give it to a child. How much must he deposit today for us to get there? Right? So this will be kind of weird because you would think I'm looking for the principal amount, which is kind of true, but that's not exactly how I will calculate it. I will calculate it like I'm looking for the accumulated amount. And how am I looking for the accumulated amount? I'm going to take this and count backwards. Are we good? So usually when you look for the principal amount, you are actually calculating backwards, and then up until you get to the final principal. So here's the formula. The formula is that when you want a principal amount, your formula says you have accumulated amount, this raised to this raised to negative n. I hope that makes sense, right? So for me to get my principal, my very principal amount here, I need to calculate from my final accumulated amount, which is 100,000, get back to my initial principal amount here. So this is the formula we are using to calculate the principal amount. So every time you calculate the principal amount, you are calculating backwards, right? I hope that is good. So since we are calculating backwards, I'm starting here, I'm going there, I'm going there, I'm going there, right? So here I am, right here. I'm looking for the first principal amount. So I have this accumulated amount, 1 plus I over 12 raised to n times 12, right? So the first principal amount I'm getting, which means I'll be moving from here, this transaction to this transaction, right? Remember, every time there's a transaction, you need to stop. I'm moving from here, I'm going there. So the amount of money that is here, I'm supposed to withdraw 100k, right? So I cannot put a negative amount here. I'm going to put a positive amount. I must have 100k at this point. 1, 2, 3. So which means also when I get here, since I'm moving backwards, when I move forward, remember I'm withdrawing 100Ks. Now, if I'm moving backwards, I'm adding 100Ks, right? If I'm moving backwards, and you'll see what I mean by that. So here's 100,000. Then we're calculating for it. I have 1 plus 0.06. As we know, it will always be like this throughout. Over 12. And I'm calculating backwards for my n, which is 36. So this is negative 36. That gives me a P1 of how much? Let me use my calculator here. That gives me a P1 of, I'll say, I'm going to do it in front of you so that you see what am I doing. 100,000, right? I have 1 plus 0.06. This divided by 12. And this we are compounding it to 36 months. Negative. Remember, the negative because we are counting backwards. This is equals to how much? 83. Right? I have 83,564,49. Okay, let's write that. 83,564,49. That's what I said, right? So from here up until I get here, that's 83,564,49. And then what happens here exactly at the end of year 3? There must be another 100,000. And because I'm moving backwards, I'm going to count it as a positive because I'm moving backwards. So I'm adding 100k here. And then I know that my P1 must be equals to 183 rands 564,49. Right? So at this point, when I'm counting backwards, at this point, I should be having 183,564. Right? Right. So I need to move backwards again. From here, I'll move 2 times and add another 100k. So let's take it from there. Let me erase this. So what's happening here? I'm looking for the second principal amount now. I need to be here, right? So I'm going to say P2 is equals to, I'm taking this because by this point I have this amount, right? That's my accumulated amount at this point. So I'm having 183,564,49. And I'm calculating this backwards now. I have 1 plus 0,06 over 12. How long am I calculating for? For an n of 24. So I'll say negative 24. Remember, I'm counting backwards. Now my P2 will be this amount. Let's use a calculator there. My P2 will be 183,564,49, right? And then this, I have 1 plus, let's put a fraction there, 0,06 over 12. This raised to how much? Negative 24. How much are we getting? 162,855. Let's do that. That is 162,855,78. And then now we are here. Do you see that? Now we are here. And what happens there? There must be another 100K there. I'm going to say plus 100K. That's my P2. So which means my P2 now is equals to, if I add 100K here, I'll be having, let's put this an SI unit. I'll be having 262,855,78. That's my P2, right? I'm here now, right? Which means now I'm only left with this final step of counting backwards, right? So let's do that. Counting backwards again. Let's remove this. My final principal amount here will be, I'll be using this because I'm here now. At this point, I have what? I have 262,855,78. I'm counting backwards with the compound interest formula. And I'm counting for how long? For this n. This n here is negative 12. Remember, it's supposed to be negative, right? And then bear in mind, at the end here, there's no 100K that needs to be added, like we did here and there, right? There's no 100K that needs to be added. This gives me the initial amount that I'm supposed to have at T0 at the beginning, which is today, right? So here I'm having, let's take out a calculator there and put this on. I have 262,855,78, and this with an open bracket of 1 plus, let's put a fraction, 0,06 over 12, close bracket, raised to, remember it's supposed to be negative. Negative what? Negative 12, because our n is 12. How much are we getting? We are getting a principal amount of 247,585,26. Let's do that. 247,585, comma what? 26. There we go. That's the amount of money here in T0. So in T0, we are supposed to have how much? 247,585,26. So I took the amount here, counted backwards. Remember, this person was withdrawing when we move forward. It means when we move backwards, it's no longer subtract 100K. It's now adding 100K, right? So I moved from here, calculated backwards for 36 months up until here, took this amount now, calculated backwards and got here, took this amount again by adding 100k, calculated backwards and got here. And here, that's my P3, that's the final principal amount, which means today this person must have 247,585,26, so that he'll be able to give his kids 100k on these time intervals. Beautiful, isn't it? Very beautiful. Next question. Here I have a very detailed question. Like, this has a lot in it, and then I would need space to write. So let's reduce this. I hope you'll still be able to see it though. Let's reduce this. Yeah, because I actually need space to write, right? So again, I need a number line. I'm going to borrow this one, copy this and put it here. Not bad, is it? It's kind of straight. I think I'll draw a number line. After drawing a number line, I'll remove all the extra details so that I'll have enough space to do my work, right? We'll see though. So let's go through the question. The question says, Jabulani opened a bank account. Let's come back here. Choose the right color. Yes, Jabulani opened a bank account on 1 January 2015. Right? So we have a T0 there. On January 2015. So let me write it down so that I know that T0 is 1 Jan 2015. Hope it's fine. Okay. Let me write it properly. This takes space. Let's write the maths date. 1/01/2015. Oh, look at that. Right? He made a following transaction. On 1 January, he deposited 50k. So here I have plus 50k, right? And then on 1 July 2016. Oh, that's far, right? So that's T0, that's year number 1. And then let's put 6 months here. End of year number 1. Sorry. Hope it will make sense. So from here to here it's 6 months, from here to here it's 6 months, right? And then again, so it's 6 months, 6 months, 6 months. So which means we have another transaction here, right? That's July 2016. What's happening there? We have 15,000 being withdrawn. Minus 15k, right? And then what else happens on 1 January 2017? So this is July 2016. This is January here. End of year number 2. Hope that makes sense. Right. On January 2017, what happens is that there's another deposit that is being made of 20k. So this is a plus, right? And interest rate is calculated at 7% per annum compounded monthly from 1 January to 30 June. So from 1 January, this is a rough sketch. Oopsie, let's fix that. From 1 January, which is from here, up until 30 June. So 6 months, 6 months, another 6 months, right there, 30 June, up until here. This thing of using dates, it's not proper. So 30 June, it's here. 1 July, it's here. Because after the 30th of June, we have 1 July. Right? So that is here. So it's 6 months, 6 months, that's 1 year. Another 6 months, which is end of June 30. End of June 30 here, right? So my I here was how much? 7% per annum, right? So 7%, 0.07 compounded monthly, so it's over 12. All right. And then afterwards they're saying And then afterwards, the compound interest was 8% compounded quarterly. So from here up until here, my I was equals to 0.08 compounded quarterly, so divided by 4, right? And then how much money will this person have by the 1st of January 2017? So 6 months, 6 months, 1 year, 6 months, 6 months, 2017. Here it's 2017, Jan 2017. Okay, I get the gist of it now. I get the gist of it, and I have it. Right? How much money will this person have immediately after they deposit 20K? All right. So let's see what we can do. I think I can remove this question. Probably I no longer need it. In fact, I'll just let's see. Let me duplicate this in case I need it. So I'll answer the question here, and then I'll keep the question here on another page, right? So let me drag this and actually put it here. Let's use an eraser here and there. What? So here we go. They want us to calculate the amount of money this person will have at the end of 2017. 2017, it's here. It's a little bit messy, but I hope you can see it. But in case it's not visible enough, I'll start afresh now, because now I see it. I see how much number line I need. I was actually not prepared for this, but I'm going to do it the same way. Okay. So let's put this thing here. Let's put this thing here, this number line here, in a nice way. Let's increase it a bit, because I think I have a bit more writing to do here. And then that was just my rough sketch. I apologize if it confused you. Let's increase this again. I want to write this in a way whereby it will make sense for you, and it's clean. Let's put this at the center. Right. So this took us 2 years, right? T0, T1, and T2. This took us 2 years. And then what did we have? We know that this thing was moving by 6 months. 6 months, right? And then another detail that I had was that on 01 January, we made a 15K deposit. So here, I'm going to put 15K deposit. Right? And this was 1 January when 2015. Right? What else happened? What else happened is that I said on 1 July 2016, 15,000 is being withdrawn. So 6 months, 6 months, 6 months, July 2016. Yes, 15,000 is being withdrawn here. So we write that. It's the date that I'm messing us up. July 2016, we are withdrawing 15,000. Hope that's visible, right? What other detail do we have? On January 2017, we deposit 20,000. So January 2017, we deposit 20,000. Right? What other information do we have? I'm moving across a lot of things. I have an interest rate now. The interest rate from January up until 30 June for 2016, 0.07. So here I'll use a different color for that, so it becomes much nicer. So I'll say that here up until this point I have an I of 0.07 compounded monthly. The other statement I had was from 30 June 26, from there afterwards I have 8% compounded quarterly. So which means from this point here, my I is compounded quarterly. I have 0.08 compounded quarterly, right? So I hope it's more cleaner now compared to the previous time. I'm not sure what else am I missing. I think I have everything here, right? So they need the amount of money at the end here. So which means what am I going to do? I'm going to move from here. There's no disturbance throughout up until here. Then I'll stop here and start calculating again from here, right? So my white pen, of course we are using compound interest because all the words they used is compound throughout, right? So my formula says A is equals to P raised to N, right? So my A, my accumulated amount number one, will be the amount of money I have here. Start with the principal amount, which is 15,000. I have 1 plus my interest was this one, 0.07 all over 12 raised to, how was this compounded? It was compounded monthly. So if I'm counting the months here, I have 6 months, 12 months, 18 months. So this is raised to 18, which gives me an A1 of, let's put it on a calculator. I have 15,000. I have 1 plus, put your fraction there, 0.07 over 12, and this raised to 18 months. This gives us 16,655. Does it make sense? 16,655. All right. Any decimals? 0.58. And what do we do here? We are going to withdraw 15,000. Was it a withdrawal of 15,000 really? Deposits 50,000. Oops, made a mistake. The deposit is 50,000, not 15. Let's come back here. The deposit is 50,000. How could I make such a mistake? The deposit is 50,000, so which means here I also need to fix this. This is 50,000, right? But the withdrawal is 15k. I'm not making a mistake there. So which means I need to fix this. Let's take out a calculator there. This needs to be 50,000. There we go. I have 55,518. Any decimals? 55,518,59. And what needs to happen here? I need to withdraw this 15k. So withdrawing a 15k there. This gives me an A1 of, come back here, minus 15,000. 40,518,59. 40,518,59. That's my A1, right? And then afterwards, I'm going to take this A1, use it from here onwards, because of my A1 is the amount of money I have here, calculated with the new details. What am I getting? I have my A2 being equals to this amount, so I put 40,518,59. I have 1 plus 0,08 over 4. What is the compounding period? What is n here? Well, I'm moving from, remember this moves in 6 months, 6 months, 6 months, 6 months, 6 months. So 6 months, it's half a year. And a year has 4 quarters. So if I'm calculating only for 6 months, it means I'm calculating for 2 quarters. So I'll put 2 quarters here. Are we good? So my A2 is going to be equals to, so I'll take this amount as an answer, 1 plus 0,08 over 4 raised 4, 2 quarters. 2 quarters. That is 42,155. 42,155, comma 54. Now, what else happened? What else happened is that at the end, this person deposited 20K. So which means on the amount that I have, I'm supposed to include 20,000 there. Which means my final accumulated amount, I add 20 there, I'm going to get 62. Wait, what is this pen doing? Is it tired? It means here I'm going to have 155,54. And that's the final amount at the end of this situation. You see the beauty of timelines. Grade 11 is different from, what is this, grade 10, right? So it's super different. Now here I have the final question, and this talks about outstanding balance on a loan. So when we talk about outstanding balance, if someone purchases an item, right? Remember we spoke about buying items, and items can be depreciating, like at this point. So let's say someone buys this printer, right? When you buy this printer, you don't have money for this printer, so you keep on paying for it monthly, and you decide that, okay, I'm going to pay this for 3 years. If you pay this for a whole year, and then afterwards you bump into some money, and you're like, you know what, I no longer want to pay this printer for 3 years. I want to pay it once off. All the money that is left, I want to pay it off. That money that you want to pay off, we call that the outstanding balance. Are we good? So back to the question here. This final part talks about outstanding balance. Okay. So this is the last question. I feel like it's too juicy. And then here's how I'm going to go about it. It says Maria borrowed 75,000 exactly 5 years ago at 21% per annum effective. Now, when you have an effective interest rate, remember we spoke about this. When you have an effective interest rate, the compounding period and the interest rate period, they are the same. So you don't need to divide I by anything. You don't need to multiply N by anything, right? So she paid back 25,000 exactly 3 years ago, 50,000 exactly a year ago. She wants to settle her remaining debt today. How much must she pay? So here's what I'm going to do. I'm going to take debt and write it with a different color, and take the amount she paid and write it with a brighter color. So let's do that. Let's calculate how much money the debt grew into in 5 years, right? So this was the amount of money she borrowed. Let me save this so that my computer doesn't crash, because it does crash a lot lately, right? I'm receiving a lot of text, so this thing is taking too long. Okay, here we go. So let's see how much the debt has grown into. This is the debt, right? The debt was 75,000. It grew on a compound interest of an effective rate, right? So Here I have 0.21, and this was staying for 5 years. Remember, if it's an effective rate, you don't need to divide I, you don't need to multiply N. It's a straightforward interest rate, right? So I'm going to check this on a calculator and see what are we getting. So I have 75,000 open bracket 1 plus 0.021, sorry, and this must be raised to 5, exponent 5. Made no mistake, right? This money is 194,530.68. Let's write it down. 194,530.68. This is the amount of money the loan has grown into currently. Right? For the past 5 years, this is what the loan grew into. Now, let me tell you something, right? Whenever you pay your loan, the amount of money you pay for that loan, that money also, it grows with a compound interest that grows to eliminate the loan. What do I mean by that? Let's take this. They're saying this person paid 25,000 exactly 6 years ago, right? I mean, not 6, sorry. This person paid this money exactly 3 years ago, 25,000 3 years ago, right? Now, you know what that does? For example, that amount of money that you paid, this is a loan. This is in the negatives, right? It's a loan. Your balance is negative 194,000, right? So now when you pay 25K, what happens is that this amount you are paying, it also grows inside the loan, right? So they are saying exactly 3 years ago, this is what, right? So the amount of money she paid 3 years ago to that loan, it has become like this now. Let me take out a calculator. 25,000, open bracket. I have 1 plus 0.21. Wait, what did I do? To erase this. I said 25,000, open bracket, 1 plus 0.21, close bracket, raised to 5. So raised to 3. Right? For the past 3 years, this is the amount of money she did, right? So that amount of money now, this is what it became, 44,289. $44,289.03. Right? This is the amount of money she paid to the loan. Now, this amount of money now, it's in the positives. Because it's the amount of money she paid towards the loan. This is the loan money, the amount of money she owes. This money, it's in the negatives, right? What else did she pay? She also paid 50,000 exactly a year ago, right? So let's calculate what that 50,000, what happened to that 50,000. I have 1,021. This is the same interest rate. It was a year ago, so it's 1. So our A here will be equal to, pull out the calculator again. 50,000. Oopsie. 50,000. I have 1 plus 0.21. And that was a year ago. I can raise this to 1, or I can just leave it like that. That amount of money is 60,500 clean. Right? So now let me show you what happens. What happens is that here's the account. Right? These are the calculations that are happening in that account. In that account, these things are calculating themselves separately. So what the bank does is that it looks at your loan, it calculates it separately. So you have the amount of money that you borrowed, which was 15,000. That amount of money now is sitting at negative 194,000. Let me write this. What is my pen doing? Like it's getting to me now. Okay, I have negative 194,530.68. Right, it's calculating this separately. It's not doing the calculations, adding them up together step by step like we used to here. So this is how the bank does things, right? To calculate your outstanding balance. It takes that your loan, it's the negative balance, and it will keep on calculating the loan at the negative balance. And then the money you put in, it calculates it with a positive balance. So the amount of money you've put in, that 25,000 you've put in, it's running on its own. And that amount of money, it's now sitting at 44,289.03, right? This is the amount of money you put in 3 years ago, right? And then again, 1 year ago, you put this money, which was 50,000. That money, it's currently running at 50,000 this way, right? And now your outstanding balance in that account, your outstanding balance, it's going to be this way. It's currently running this figure that it keeps on going on, and it also runs the amount of money that you keep on putting in. That money also keeps on running up until the amount of money that you put in cancels out the amount of the negative value that keeps on growing. So the more amount of money you keep on throwing in, the more it will eventually keep on adding up to an extent that it will cancel out this red money that keeps on growing there. It makes sense. So now your outstanding balance, take out your calculator there, you have negative 194,530.68, and you have the positive balance, which is 44,289.03, and then you also have another positive balance, which is 60,500. Press equal sign. So far your account is sitting at negative 89, but of course you're going to write it as a positive answer because you are telling us the amount, right? So it's negative 89,741.65. Let me put it here. You're going to give me this answer as a positive value, right? Because you're not a bank. So we're going to say the outstanding balance, hence I wrote the word outstanding balance. Your outstanding balance is 89,741.65. It was 65, right? Yes, 65. There we go. So this person now, today, after making all those deposits, she still owes the person who, the bank, 89,000 for the loan she took, right? So this is what we have. Are we good? So this is how you make those calculations. I hope it makes sense. And then this actually reaches the end of our video. And then if you've reached this far, you should be proud of yourself. And I'm actually happy with myself that this video actually took exactly 2 hours, or less than 2 hours. This is the part where I actually talk up until it reaches the 2 hours that I want, of course, right? So, but then thank you very much for reaching this point. If you enjoyed the video, please like and subscribe if you haven't subscribed. I'm surprised that people still haven't subscribed. And what else am I missing here? Also, if I made any mistakes, please throw them in the comment section so I can see them, I can notice them. I can always know that this video has these small mistakes here and there, right? So otherwise, thank you very much, guys. I'll see you on the next video, which will be about solving past papers on financial maths. All the best, and if you're writing anytime soon, all the best again. Goodbye.